Hello, hello. All right. Let's change that. This should be make that bigger. And this two. Hello, 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 hello. All right. Okay. All right. I think it should work. Let's see. Yep. Let's see. Okay. Bum, bum, bum. Let's see. Some study music. Some study music. No. Something better. How about this? Yeah. Bum, 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 let's see if we can do that question. 304, 15, okay. Oh, okay. So, okay, let's pull up that idea real quick, okay. So, what you're asking us to do there is to use the distributive property to rewrite each expression. Okay? Okay. Let's talk about this first, right here. What does this mean? Okay? What does use the distributive property to rewrite each expression? Okay? Let's just look at that. So you have the number 304 and 15. Okay? The part that a lot of people is getting is rewrite each expression. What rewriting the expression means, in other words, is to break it down into two parts or other parts. Okay, so look, the goal here is I am going to break down the 304. Okay, the reason why is because 304 is ugly. Okay, right, so if that's being said, let's do it. 304 is going to be broken down into 300 plus 4. Okay? Is that straightforward? Okay, you see how here I break it down into 304. Okay? And you see the 15 is still there? Right? Okay? Nothing happened to the 15. Okay? Nothing happened to the 15. So now you distribute the property. Okay? Now you use the distributive property. The 15 will need to be multiplied into each term. Okay? Right? The 15 will have to be multiplied to each term. Okay? Right? So 15 is going to be multiplied into 300. Right? And do you see the plus symbol here? Plus the 15 also has to multiply into the 4. Okay? I'm going to stop here. Okay? Do you get the steps, Danielle, at this point? Or do you have a question on one of the steps? Are you okay here, or would you like... Are you okay from the steps here, or is there like a question that you would like to ask? Okay, so you're good from here, right? So from here, right, a lot of people will not show this step and they're going to make their mistake. Okay, from here you just carry on evaluating it, right? This would be 45, 1, 2. Okay, let me make this red for you. And then that is red, right? And this I can make blue. Okay, and that is, I think, 30, 60. So together that should be 4560. Okay, so this is how to do that problem, right? If you have a specific question, let me know, okay? Okay, so right here, that covers everything. I think many of you just go from this step to this step, and that's bad. You have to show this step. You have to show, this is the breaking down step here. This is the break, this is the what they call this, the rewrite each, this is the rewrite each expression step here. Okay, here, right? That's what that part of the question says. Okay, rewrite each expression is this part. Then you carry on the distributive property. So here would be just the distributive property again. Distributive property. at this point, okay? And this is just the distributive property step, okay? Alright, but this is the breakdown expression step, and this is the distributive property step, right? So we'll wait for another question. Good question, good question. Okay, so let's go to if you have a specific question about like a step, let me know. Just gonna wait for more questions to come in. What number is that one? Is that, Edward, is that just a simplifying one? Is that just simplifying? Here, let me write it. I think this is it. Okay. Alright, so here, the problem here asks us to simplify. Okay? What simplifying means is to, right? Means to, its simplest form, remember it has no parentheses, or, right, has no parentheses and no more like terms. Okay, remember this is the definition of simplest form. Okay, we have to have no more parentheses and no more like terms. Okay, you have to understand the idea before you know how to start solving it. First of all, okay, right, first of all, you have to worry about the parentheses, right? You have to worry about the parentheses, okay? Worry about the innermost parentheses. Inner means like the one inside the most, right? So the one we're probably gonna look at is this one. This is the innermost one first, okay? So this is the innermost one first. Alright? So let's just rewrite the other, right? Nothing happened here, nothing happened here, nothing happened here. But 2x plus 5 becomes 7x. Is that fair? 2x plus 7x equals 2x plus 5x equals to 7x. Okay? Now, okay, right? Now, notice, right? I'm just going to ignore this, I'm going to ignore this, and I'm going to deal with this. This is just a -1, right? So this can just be broken up into just 7x. Okay? Because I distributed the negative in. Good? Right? So here, this is when I distribute the -1 into the parentheses. parentheses. Okay? Then now I worry about this. Right? The other part. Okay? Right? Because I work in the innermost one. So 9x minus 7x becomes 2x. Okay? Now I distribute once again. This becomes, right, negative 2 times 2x becomes 4x. Okay? Now, this is simplified. This is its simplified. This is this is already simplified. F. Okay, this is already simplified, right? Because there is no more parentheses or no more and no more like terms. Okay, there you go. So you would consider this, it's simplified. Okay, alright, but look, deal with the innermost one first and make sure you're very careful with that negative here. Okay, that is this solution here. So you can multiply a constant with a variable term. No, there is no, what are you doing? Yes, you can multiply, correct. Yes. So yes, you can multiply a constant with a variable term. For example, 2 negative 2 parentheses 2x, okay, is equal to negative 4x, right? Okay, this is your constant and this is your variable, right? When they multiply together, it gets you a variable. You can, yes, you can multiply, right, a constant term with a variable term, but you cannot add a constant with a variable term. Okay. Alright. Like, you can't do this. You can't do this. Nuh-uh. You can't do this. Alright, this is no-go. This is bad. Alright, you can't do this. This is no. This is bad. Bad. Okay. Alright, let's just look at the next one. Hold on. Someone's asking another question. I think that's a function question, right? Okay, let's insert the equation. Let's see. Here's the function. 3x minus sub. Okay. Black, good. And let me unbold it for you. Okay. Here's the function, right? This is the function. Okay, and they asked us. Okay, they asked us. Right? Find f of x when x equals to 6. So x equals to 6. Okay, so let's do that. Okay, we have to plug it into the function notation. So, okay, you see x is replaced by 6. Right, we're making the substitution, so this also has to be replaced by 6. Okay, let me see. I replace the x. I substitute x. I replace the x with a 6. Because again, the reason I do that is because that's what they're asking for. Okay, now I just do the math. Okay, 3 times 16 is, no, 3 times 6 is 18. Right? Then afterwards, do the subtraction. So 18 subtract 7 is 11. There you go. Okay, that would be the solution for your evaluating the function at a given value. So yep, good, good, good. That's the question, right? Keep the questions coming. Keep the questions coming, okay? Ask any question you want in chat, okay? Keep the questions coming. Keep the questions coming. Keep calm and ask me anything. Alright, so how about you give me an example? Okay, how about you just give me an example? Okay. Give me one of the properties and we could talk about it. Okay? Those properties you just have to remember. So Danielle, give me a property and we can make example for you. Or Edward, Art, give me a question. There's different examples, like you have to give me one. You have to tell me what number you want to see. Yes. So we yes the note card, yeah. Well, you can't use the note card on the test. You cannot use the note card on the test, but you can study it to memorize the property. Okay, there you go. And Edward, you have to give me an exact question. Chapter 1 test review. How about we go over this one? How about we go as this one? Alright, how about I ask you this question? Is this a function? Okay. Is this a function here? Is this a function? That's my question. Is this a function? Okay. How do I know if it's a function? How do I know if it's a function? Okay. Right? The idea is that pretend you have a vending machine. Okay? If you press the button, right? Let's say you press the button E1. Okay? You should get the candy that is in E1. Right? Is that fair? Is that fair, this idea? Right? You use a vending machine, right, Edward? Okay? you should get the candidate that's in E1, right? However, okay, so let's look at this one, okay? Okay, if you press -2, then you get -3, right? Because this is the domain and this is the range, okay? Are we good so far? Next, if you press 0, then you get 6. Alright, the machine knows what to do so far. If you press 3, look at the 3, it gets you 6. Alright, that's good so far. Alright? If you press 4, then you get 9. Alright? You see? Everything works. Everything works here. So, it's a function. Okay? But, right? Let's see something else that might not be a function. Okay? Alright, let's see. What about this one? What about this one? Okay. What about this one? Let's do this one. Okay. Let's put this on the side, right? Here. Okay. Alright. And let me open up another one for you. Alright. Okay. Let's do that side by side here. Okay. What about, let's ask this question. Is this a function? And we have this. Okay. Right? So, let's do our vending machine example again. Okay? Right? If you press the button 2, if you press 2, then you get 6. Right? Based on this picture. Right? 2, 6. Okay? 2, 6. Okay? 2, if you press 2, you get 6. That's good so far. Okay, let's do another one. If you press 5, then you get 7. That works. Right? If you press 6, then you get 9? What? You get 9? Or if you press 6, then you get 10. Because look, do you see these two? Right? These break. Right? And it's based on this. Okay? That one, that is what's playing with you here, is this term. Okay? This is what's causing your problem. Edward, do you see? This is causing you that problem because the machine here, the vending machine, doesn't know what to do. Does it give you 9 or 10? Right? It breaks down because it's not a function. Right? There you go. You see? Right, and I think someone asked about, Danielle asked about the commutative property before. So let's, okay, so you're good, right? So here, let me just bring this over here because I just want to work on one doc here, okay? Boom, there you go, right? Here's the doc, okay? Good, that's not a function. You could always go back, okay? And I think someone asked about the commutative property, okay? So let's do that. Commutative property of multiplication. I think that's how you spell it. Okay. Let's change this. So let's change this, okay? Another name for commutative is, we call this the rearrange. Okay? Property of multiplication. Okay, to be honest, this is not something that you should try to understand. This is just something that you need to just memorize. Okay, you just have to understand how it functions. Okay, here's the idea. Okay, 3. Okay, let me just put it into the example here. Right, here's the equation. Okay, 3 times 5 times 2. Okay, is equal to, what is 3 times 5 times 2? That looks like it's 30. Okay, right? Okay, is that fair? Right? Does this step make sense? Right, it's just multiplication. Okay, hold on, I will go back to your question, Edward, okay? So this is the commutative property. So 3 times 5 times 2 equals 30, right? So that's the idea. But what about if I ask you this? Okay? 3 times 2 times 5. What is that equal to? 3 times 2 is 6. 6 times 5 is 30, right? Okay, see how it doesn't matter the order in which you multiply. Multiply, right? So you can rearrange. Okay, so the commutative property, here's the example. Ready for the example? Right, that's the idea. The idea is up there. Now let me give you an example. Okay, the example would be 3, okay, times 5 times 2 is the same thing as 3 times 2 times 5. Okay, see that this is the same. See that all I did was rearrange. Right? Do you see that all I did was rearranged? Okay, and the answer still stayed the same. Okay, so this would be an example of the commutative property. It's just rearrangement. Okay, so hold on, let's go back to Edward's question. So Mr.S, so if you have 2 or more exact the same domain, it's not a function, right? Yes, right? So going back to your question, Edward, yes, right? Because look, if you press 6, you get a 9, or if you press 6, you get a 10, right? You see how it's twice here? Okay, so yes, your question is correct. You are right, Edward. Okay, that is the example of the commutative property. Okay, here, this is another example, right? We could even use x, y, and z. Okay, if you rearrange that, right, x, y, z, you can rearrange that to z, x, y. Okay, I rearranged that. This is also the commutative property. Okay, you could even go right, anything else. You could even go 3 RT is equal to the same thing as 3TR. Okay, that's also the commutative property. Right? Doesn't matter what you do, no matter how you multiply, right? It does not matter the order in which you multiply. Okay? Right? That is just the fact of the commutative property of multiplication. Okay? If you have any other properties, let me know. Okay, that you would like an example for. Okay? Let's see. Let's go. Pa, 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 pa. Boom, boom, boom. Boom, bam. Okay, and let me turn back the image. Yeah. Keep calm and ask me anything. Ask me any question you would like answered. Alright, let's see. I see another question. Okay, thanks. So the multiplication identity is just two numbers being multiplied, and the additive inverse is just two numbers being added. What? Okay. Hold on. Let's review this. Okay, hold on. Multiplicative identity. Okay, let's talk about this. I don't know if what you're saying is correct or not. Okay. What is this thing called multiplicative identity? Multiplicative identity is defined as, okay, multiplying the struggle is real by 1 and getting the same thing. Okay? Okay, so here is your example. Okay. Alright, give me a number. How about 10? Okay. If we multiply that by 1, we get 10. Right? See that you get the same thing again when you multiplied by 1. Right? Oh my, sorry. Multiply. Right? I think this. Yeah, by 1. Good. And if there's any in place, please show how to solve them using any property. Okay. There you go. Okay. Or the other one I think you talked about was the additive. So this is the multiplicative identity. Okay. Right. Okay. So this is one thing. The additive inverse. Okay. The additive inverse is something completely different. The additive inverse. Let's make this bigger. The additive inverse. Okay. Is when, by definition, right, you add the opposite to get to make 0. Okay? Here's the example. Give me a number. How about 9? Okay? How do you make 0? You have to add, right, its inverse, -9, and you get 0. Okay? This would be the additive inverse. Okay? Right there. That's the additive inverse. Okay, you add the opposite to make the number 0. Okay. Right, so that's the additive inverse, and that is the multiplicative identity. They're different things. Do you want to talk about the multiplicative inverse? We could talk about that. Multiplicative inverse, okay, is when you multiply, okay, the reciprocal to make 1. Okay. So, let me give you the example, right? Let's say I have 9. What can I multiply by to make 1? Right? It would be its reciprocal, okay? Think about this as really 9 over 1. You multiply its flip, right? Which is going to be 1 over 9. When you multiply, okay, you get 1, right? Do you see how you make 1? Right? See how you make 1? Right? You made 1, right? Okay. The reciprocal, right? The reciprocal, right, of 9 is 1 over 9. Ah. 1 is 1 over 9. Okay. There you go. Alright. There you go. That is the multiplicative inverse. Let me take off the picture for you. Okay. Scroll that up so you can see. Okay. You can always go back and rewatch the videos if you want me to, after this. Okay. Alright, so ask me anything else. That was the first 41 minutes. We only have an hour and 20 minutes to go. Okay, an hour and 20 minutes to go. Ask your questions now and study. Right? Alright, stop wasting your own time. Ask me any questions you would like for problems to be worked on. Let's go, let's go, let's go. Yeah, okay, so let's talk about discrete and that's a very good question, okay? So, let me give you an example of something discrete, okay? Discrete Let me pull up an example for you, okay? Boom, perfect. Right here. This is the best example I could give you. Okay? This is the best example I could give you. Okay? Right? This is a discrete graph. Okay? Notice that, right, your ages, right, and height, it's discrete, okay? Because you don't have like 1.5, okay? Right? Do you see how it's all dots, right? And there's gaps, okay? Right? If there is a gap, right, and just dots, okay, it is discrete. Is that fair? Right? It is discrete. Discrete. Okay? Right? Do you notice that? That's all what the discrete is. But if it is, you know, a line, okay? Right? If it's a line, okay? Or a curve, okay? Then it is continuous. Okay, look. You see how this is continuous, right? Because it's like a slide, okay? It is like a slide. Okay, alright? So that is the difference between discrete and continuous. Okay? Daniela is asking, wouldn't the additive example be for the additive inverse? Okay, you're asking two different questions, okay? So here, multiple. So this is the additive inverse, and this is the additive identity, okay? This is when you add 1 to get, no, this is to add 0 to get the same number again, okay? So here's the example. 9 plus 0 will get you 9, okay? Do you see adding that 0? Right? Do you see that adding this 0? Oh, let me make this red. Do you see that adding that 0? Oh. Okay. Okay. Come on. Okay. Do you see that adding that 0 gets you the same number again? Okay. That's what the additive identity is. Okay. Additive inverse is completely different. Okay. You are trying to get the number 0. Okay. Okay. The additive inverse, you're trying to get the number 0. Okay. But this time, you're trying to get the same number again. They're two different things. The identity is different from the inverse, okay? Let me just make that smaller so you can see it on the screen. Okay? Here, let me do that. Alright? Let me highlight this yellow for you. Boom. Okay? They're two different things, okay? Alright, does that clarify your question, Daniela? Edward, okay? Hopefully you understand that this is discrete, right? All the dots are discrete, okay? There's gaps here, okay? Like, you get 1 customer, 2 customers. You can't get 1.5 customers, okay? Alright, here, I can make this bigger for you if you want. Do you see that now? Do you see the graph now? Right? Alright, we have another question for why don't you solve for f? Why leave it as... Wait, what? Okay, hold on. It is solved. Where is that? where's that function question? Hold on, where's that function question? Where's that function question? Oh, right here. Okay. This is solved, right? This is already solved, right? Because the question, okay, the question is asking us for this. Okay? That's what the question's asking for. What is the function of 6? Right? Right? It's asking for what is the function of 6, right? F of 6. We said it right here. We said it. This statement, okay, says it. It says what we want. This statement says f of, right? F of, F of 6, this is how we say this, f of 6 is equal to 11. So it's what you said, it's solved, right? This is already solving, right? Solving is trying to find what does this variable mean, right? What does this function mean? And we said it, it's right here, it's equal to 11. This is solving, right? We solve for the function right here, okay? So on the test, you will just figure out if the equation is one of the properties. Well, there's different ways, Danielle, that the question can be asked in terms of like the property, okay? You just need to be able to, you need to know the name of the property. Okay, you need to know the name of the property. You must know how to give an example. You might need to, like, let's say I give the example, right? Let's say I give you something like this, or this, or this. You might have to tell me that that's the commutative property, okay? There's different ways that we can ask you that same question, but it's the same idea, right? Do you have your properties? Do you know the name of your properties, right? And do you know how to look and find the properties, okay? Alright, here, let me see where's the property page. Yeah, right? Okay. So those are all the different ways it can be asked on the test. Alright? There's different ways that single question can be asked. What's the question? Is there anything else that is there on the test that we didn't review? No. The review covers, so let's make this really note. The review covers all the topics and content that will be assessed on the test. Okay? That will be asked. That's a better word. Alright, on the test. Okay, there's okay. Right, so 6:53, only an hour and 10 more minutes. So get your questions answered as soon as possible. Alright, ask ask any questions you need clarified, right? Any questions, right? What's this step? What's this step? Right? Anything you need. Alright, here, let me leave up this discrete and continuous graph, right, for Edward to look at. There you go, Edward. That's just for you. Alright, I'm waiting for another question to come up. Just waiting for another question to come up. Alright, what is number 20? Let's see. What is number 20? Oh man, the ugly one. Okay. Alright, let's see. Boom, boom, boom. Okay. Boom. So this is the problem, okay? And I think this asks us to simplify, correct? Okay. Okay. Listen very carefully to what I'm going to say. Okay. You need to deal with this negative here. This is a very, very ugly thing, is this negative. So, this, I hope you understand that this is the same thing as this. Okay? This is the same thing. Okay? Are you aware of that? Okay? Now, what you need to do is, let me show you. Alright? I'm going to distribute that -1 into everything. So ready? Okay. Hold on. Okay. Do you see this? Do you see how I'm distributing that -1? Do you see that? Do you see that? Do you see me distribute the -1 to each term in the parentheses? Okay. Right? That's the reason I do that, is to get rid of this negative, okay? So what I get in return is this. Okay, I get a negative xy, and I also get a, right, negative and a negative. I get me a positive, okay? These are the two things I got in return. Good? right? There's an easier way to write this. We can just rewrite it, right? Rewriting it. We don't write plus a negative, right? We just call that, okay? Alright? Straightforward, okay? Right? So, what happens is, okay? Right? Then we can drop this parentheses. Woo. Okay. So, there you go. This is the next line, okay? I just get rid of the parentheses. Nothing changed, okay? Right? Okay? Multiplying by 1, okay? Good. Now I can just rearrange, okay? Let's rearrange, okay? The reason I want to rearrange is so I could combine like terms, okay? There's nothing here. Alright, there is a plus 2x, then a minus 2x, then a minus 4, and a plus 10. Okay? Do you see how I combine? Right? I rearrange it. I did some commutative property. Okay? I did some commutative property here. Commutative property. Okay? So I can combine things. So let me show you the next step. So boom. So these two, okay, these two buggers here, right, is going to get me 2xy will get me 1xy. Okay? Do you see how those two buggers come together? Okay. Then the next line, I'm going to grab these two. Grab these two, right? And I can make that this color. Let me just take that away. Okay. Stop. Okay. All right. Okay. I'm going to grab these two, and I'm going to combine them, and I'm going to get plus 6, right? Right? Look at that beauty, okay? In the end, I can just rewrite it as this, okay? Do you see how I combine both of these because these are like terms? Then these are also like terms, okay? Are you good, Alex? Do you have any questions before I move on? Do you have a question about any step? Okay. Let me make it smaller for you here. Boom. Okay. I can call this let me do this. Boom. Do you have any questions about any steps, Alex? Any questions? Any questions at all before I move on? Okay? Um so this is the same thing. Oh my god, my come on, keyboard, is the same thing as xy. Okay, this is the same thing. This little bugger here, this little bugger is this. Come on, stop. Oh my gosh, it's doing the whole thing. This thing here is the same thing as this. Okay? So there's no, so you can either get it, right? You could either put any one you want, okay? So and the next one is on the test, which you that's fine. Can you review 21 on the worksheet? Sure, I could do 21. Okay. Boom, 21. All right. Same thing, right? Same idea, right? You need to, right? When we simplify, okay, it's just asking us to simplify, right? Okay. So, like what I write, right? No more parentheses or like terms. Okay. I don't know how to spell parentheses. Parentheses. I think that's how you spell parentheses. Yeah, parentheses. All right. Okay. Right. To simplify, you have to get no more parentheses or like terms. So let's deal with it. Okay. Right. So here's step 1. Okay. Boom. Step 2. What do we do? Right. Let's combine these two. Okay. Let's combine these two. That becomes a. These two become a 7. Okay. You see that? Good. Right. Now you can just rewrite it. It just becomes. Right. This just becomes a minus 7. Good. Right. We cannot do anything on the inside of the parentheses. Okay. So now we're going to distribute. Let me show you the distribute. The 2 is going to be multiplied into. Right. So, do you see this plus 2? Right. Let me just make this red. Okay. Do you see this negative 2? Right. This is going to be distributed. Boom. Boom. Oh. Like this. Alright. Is going to be. Alright. That's going to be distributed here. Do you see this? See how the negative 2 is distributed into each of the terms inside the parentheses. Oh man, for all the much time I spell parentheses, I should remember how to spell it. Parentheses. Okay, good. Alright, then you can combine things. This, okay, I can make that for you. That becomes, I think that becomes negative 18. Right? Negative 18x. Okay. This is stupid. Alright, there you go. Okay. Then this becomes something else. So, okay. Right here. Right. So you know what? I'm going to do something really interesting. Do you see the negative here? There's 2 negatives. You could just make that a positive. Okay. So that becomes positive. Right. 14. Do you see that? Okay. Let me make this. No. No. Yeah. Do you see that? That becomes the 14. Okay. Are you good here? Right? It's yellow, right? Yellow. These two. Negative, negative, right? That becomes a positive. 2 times 7 is 14. Okay? Then you have to combine one more like terms. 36 and 18. Let's look at that. Hold on. 36 plus 18. 54. That becomes 54x plus 14. Right? And there are no more like terms, right? There are no more parentheses or like terms. So this would be your final answer. Okay? This is your final answer. There you go. Okay? That would be your final answer. Okay? Alright? That would be your final answer. Okay? Here. Do you have any questions or any of the steps? Okay. Who asked me this question? I know someone did. Wait, isn't it 36x minus 18? Hold on. What do you mean? Wait, what? Are you might be looking at a different problem. What do you mean? Johnny, you're wrong. What do you mean? You know we're doing number, what number is this? This is number, I think this is number 21. Yeah, this is number, we're doing number 21. Alright, we are doing number 21. So, step 4. Okay, what about step 4? So, 2 plus 5 is 7, right? Distribute it over, this becomes negative 7, okay? Distribute it over, Negative 2 times 9x equals 8. Ooh, wait, hold on. Oh, you're right. That looks like it's a subtraction. Hold on, is that right? Yeah, that is a negative 18. Ah, yeah, you're right, you're right, you're right. That's a negative 18. This becomes 18. Yeah, you are correct. Okay, yep. Caught the mistake. Caught the mistake. Yep. Yeah, it's right here. I screwed up right here. Okay, right, so caught my own mistake. It's because a negative right here, the negative 2 here, so this is still negative, right? So, yep. Good, good, good. Right, wait. The answer is what? No. No, it's 18x. Yeah. Yeah, 18x plus 14. Yep. We caught our own answer, right? We caught our own error, so that's good, right? We're learning from our mistakes, right? That's why, again, it's very crucial for you to show all those steps like that. Okay? If you didn't show that step, right, you couldn't go back and check, right? This is why this format of doing the problem top down and showing all the steps, you can actually go back and check, you know, how things came to be and what number is becoming what. So, alright, if anyone else has any other questions, let me know. We are less than an hour away, so, okay, less than an hour away. Alright. Alright, we only have 50 more minutes. 50 more minutes. Alright, ask any more questions, okay? Ask any questions you need. Ask any questions you need. Okay, let's bring back the message. Boom, 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 boom. Okay, alright. Refresh on the vertical line test. Okay, we can do that. So, vertical line test. Vertical line test. Okay, let's look at this. So, this is the idea, okay? Let me give you the idea, okay? When you draw a line straight down, okay? When you draw a line straight down here, okay? When you draw a line straight down, since it only touches once here, right? It's a function because, right? The x value, right, has only one y value. Okay? Do you see that? Okay. But let's look at it.
We want to determine if...
Okay, let's look at this. Copy image. Let's go over this scenario, okay? This is a bad picture. Hold on, hold on, hold on. Let me pull up this. Okay. Vertical line test, vertical line test. Give me a second here. Give me a second, give me a second, give me a second. Okay, cool. Alright. But what about if you have something like this? Okay? Notice how if you go straight down, okay? So here, let me write for you. Notice how when you draw the vertical line straight down, you pass through to y value. Uh-oh, this is the red flag here. This is the red flag. Uh-oh, that is the problem here. That is the issue, okay? So, because you do that, because you pass through more than one point, it's not a function. Alright, let me make this smaller so you could see it all on one screen. Boom, boom, okay. Alright. Do you see? We could even do a side-by-side comparison, okay? Here, let me show you. In front of text. Okay? So this is a function. Okay, this is a function. But this isn't. Alright? This is not a function. Okay? Because you pass through more than one point. It is not a function. Okay? There you go. This is what you need to know for the vertical line test. Okay? It's a test to see if it's a function or not a function based on that rule. Alright? Okay, any more questions? Okay, we're waiting for more questions. Can you review number 20 on chapter 1? Okay, I think we already did 20, but okay. Yes, okay. Okay, we could go back to 20. I think we did 20. No? Did we not do 20? Hold on. Is that 20? Yeah, right here. This is number 20. Okay. I'm going to leave it up right here. Okay? For you. Alright, Alex. Okay. Hold on. Edward. I'm going to give a chance to Alex for to ask me that question. Hold on. Alex, you said you wanted to look at number 20, right? Right now? Okay. No, I think Alex, okay, I saw this chat wrong. And can you explain the difference between the x value and the y value to the, okay. So, I'm not sure what you mean here. Can you explain the difference between the x value and the y value? I'm not sure. Edward, you gotta rephrase your question. I don't understand what you're trying to ask. What happens when you hit two x values? You know, someone asked this question. This is a very interesting question. Okay? What happens when you hit two x values? Is that possible? Is that possible when you draw a straight line, though? Alright? Okay? Really ask yourself this question. Alright? She asks, what happens when you hit two x values? I'm going to ask you, is this even possible? Is this even possible? You can't. It's impossible. Right? It's impossible. It doesn't make sense. You can't even ask that question because when you draw a line straight down, it only passes through one x value. Okay? That it's why it's called a vertical line test. It tests one x value. Edward, again, you have to rephrase your question. I do not understand what you mean by, can you explain the difference between the x value and the y value to the x-axis and the y-axis? I'm not quite sure what you mean by that. Okay. Okay. Is there a difference between a value to an x? Well, okay, so an axis is just like a number line, correct? And on a number line, there are different values, okay? Right? So, right here, I can even draw this for you. How do I go to paint? Hold on. Do I have a brush? Okay. So this, right, is an axis. Okay? This is an axis. Okay? And this are your values for your axes. Okay? They're two different things. Okay? What if, okay? So these are values, and the whole thing is called the axes. So the number line, right? The number line is the, axes, right? You could think about it that way. Okay? The number line is the axes, okay? And each number is a value. Okay? What if it's on a map like domain and range? Same thing. Well, okay, well, we got to look at that. I mean, what happens if it's on a map? Let's look at map, right? Map, not a function. Image. Okay. All right. Let's look at this example, okay? Let's see if I could. Nope. That's a. Let me go to here. Okay. Here's a mapping method. Okay. Okay. This is a mapping method. Okay. This is right. So here, well, let's bring this down. Let's bring this down. So let's use the vending machine example again. Okay. Again. Okay. Vending machine. Vending machine. Vending machine. Okay. So if you press a 1, you get a, right, the candy here. Okay. Let me just make this dark. Okay. If you press 2, you get B. Wait. If you press 2, you get C. Uh-oh. Do you see the contradiction? Boom. You don't know, right? So do you get B or C? The machine doesn't know. Okay? The machine breaks because it's not a function. Okay? It's not a function because this screws it up. That 2 screws it up really bad. Okay? Hold on. Let me get you a picture of it. Okay? Right here, look. Right. Well, so do you see this? Okay. The problem is this thing here. This 2 is causing the problem. Should you go here or here? They don't know, right? This breaks it. This is the thing that breaks it. Okay? That is not a function. This is not a function. Okay? Not a function. Okay? Alright? So, I hope that answers your question, Melissa. Okay? So, does that answer your question, Melissa? Right? Okay, I could put this on the side, scroll this down a little bit for you so you can see the whole thing, and have the picture up. Okay. There you go. There you go. Ask your questions now. We only have roughly 40 more minutes. Look, Melissa, if my explanation does not make sense, stop me. Like, please tell me, like, what do you mean by this, right? If there's a, like, if you're still confused, right? Or like, if you're confused by the vending machine, right? Tell me. I don't get your vending machine example. Can you give me another example, okay? Just tell me. If it makes sense, it makes sense. If it doesn't, tell me and I will explain it a different way. Where's my music? All right, let's play some studying music. All right, I'm actually waiting for some questions, so. Just waiting for more questions from you guys so I can start answering it. Okay? Can you do number 17? Alright, let's see. Alright, where's 17 at? Let me look for 17. Hold on. Chapter 1 test review. Number 17. Number 17. Okay, sure. So let's look at this. Okay. Number 17. Hold on. I think I did one of these right here. Okay. Let me. So it asks us. Okay. The idea is this. Okay. Use the distributive property to rewrite Use the distributive property to rewrite each expression to break it down into two parts, okay? Do you understand the directions, okay? Here, the problem is this, right? Okay? For this problem, I'm going to break down the 2 1/2. The reason why is because the 2 1/2 is very ugly, right? It's a mixed number. It is very ugly, okay? So let me show you exactly how I break it down. Ready? Ready? Okay. The 2, I'm going to break it down. Ready? 2 1/2 is 2 plus 1/2. Okay? There you go. This is the breaking it down step. Okay? Boom. Step 1. Are we okay here? Are we good? Are we good here? The breaking it down? Right? We're breaking it down. Okay? Do you want to break up the 20? Sure. But I'd rather break down the 2 1/2, right? Because that's ugly. Okay? Are we good here? Now you want to distribute. Okay? So the 20 is going to be multiplied to the 2. Okay? Right. Plus the 20 is going to be distributed into the 1/2. Okay? Here, let me make the color, right, for you to make it look better, right? So you could sort of see it much better, right? Boom. Boom. Okay? Do you see here? I am distribute the 220 to each term inside the parentheses. Right? Do you see that step? Do you get that step? The breaking it down step. Then this is the distributive step. Now I can make some substitutions. 2 times 20 is 4t. Okay. Let's make that black so you can see it much better. Okay. So that's 40 plus 20 times 1/2. That's 10. Okay. Right? This is just okay, doing some algebra, right? Then the next step, I would get 50 as my final answer. Okay? Right? So, Alex, do you have a particular question? Right? Is your question on how do I break it down? Is your question on distributive property? Is your question on why do I pick the 2 1/2? I'm not really sure, you know, where your confusion is. Alright, if you ask a more specific question about number 17, then I can help you out. Because 90% of you get it wrong because you just refuse to do this step. Right? It's so ridiculous how many of you just refuse to do this step, right? Because you don't write this step, you are 95% of the time going to get it wrong. And it's so funny how I keep telling you guys the same thing over and over again. Write all the steps, write all the steps, right? And you're like, I don't get it. But when I write all the steps, now you get it, right? It doesn't make sense, right? That shouldn't be the problem, okay? Writing the steps out, you need to do it if you really want to understand it. Okay? Right? Here, I try to work it out as clean as possible for you here, okay? Come on, Alex. Come on, Alex. You got this. 30 more minutes, guys. 30 more minutes. 30 more minutes. Can you do 42? Yeah, let's see. Hold on. Alright, let's see where 42 is at. See what 42 is. Oh, yeah. Wait, I thought I did 42, no? I think I did 42. Didn't I do 42, guys? Hold on, hold on. I know I think I did. Right? Wasn't this 42? Yeah, this is 42. So, right here. Here's 42 for you. Joseph, do you see it? So, this is the function that you have, okay? This is the function. Right? This is the problem. This is what the problem gives you. Okay? The first step, right, is I replace the x with the 6. Good? This is the replacing step. Okay? Alright, I replace it. After I replace it, right, I make this substitution here, right? 3 times 6 is 18. Good? After 18 minus 7, that gets me 11. Okay? So, right, in the end, right, 18 minus 7 equals to 11. So the function of 6 equals to 11. Okay? Does that clear it up? Do you have a more specific question on the steps? Right? It's like, how do I start? How do I read it? You know, what am I trying to figure out? What does the f of 6 mean? I mean, so if you ask me a more specific question is, so you don't touch the f of 6 at all? No, so think about this. Ready? I'm gonna do this problem again. Ready? Think about this as like y, right? Right? You see? Right? You see? Do you see that? Right? Yeah, right? So, this is the same thing, right? The reason why they introduced this notation, right, is just to tell you, you know, you're substituting x in for 6. That's the only thing. So, that is good that you get it now, okay? So, Good. Ask me any more questions, right? Come on. Keep going with the questions. Keep going with the questions. Keep throwing me some questions and I will answer. Alright, let's look at this. 37. Wait, hold on. I'm still not getting why it's continuous. Hold on. What? Can you do 37? Okay. Alright, hold on. Let me look for 37. Is the graph continuous or discontinuous? Okay. Look, ready? Look, ready? I'm just gonna give you. Hold on, where is that picture? Right here. Okay. Alright, here's an example I gave to Edward, okay? Okay. The picture for 37 is this. This, the fact that it's a dot, is this discrete or continuous? It has to be discrete, okay? Right? It is discrete, okay? Because, see how there are gaps, okay? Right? Good? Does that make sense to you, Joseph? Alright, that is... you might be overthinking the concept of discrete and continuous, right? If there's a gap, it's discontinuous. It's discrete, right? Okay, if you have a more specific question on, like, can you give me examples? Or, like, I don't understand why a laptop year is, like, there's gaps. So it's only continuous if the line's there. Yeah, look, right here, boom, right? Yeah, this is continuous. All these are discontinuous, right here. These are all continuous. Do you see this? Right? Continuous. These are all continuous, right here. Okay? Refer to this chart. Yeah, they're all lines. Okay? Even these curves down here, these are also continuous. Okay? Alright, so use this chart for reference. Because the lines connect all the points. Yeah, right? Yes, this is continuous. Yes, there's no gaps. Correct. No gap means continuous. Good. Yes, there's no gap. Correct. No gap means continuous. You are correct. Let's go to 41. What do you mean no, Edward? I don't get your question, Edward. Do not connect the lines. What? What do you mean? What? So, okay, hold on. You guys are confusing yourselves, okay? Let me get paint out. Okay. Alright, do you see this? Do you see how there's gaps here? Right, there's gaps here, there's gaps here, right, gaps here, right, these are all gaps, okay? The fact that there's gaps is the reason why it's discontinuous, it's discrete, okay? That's the reason why it's discrete, okay? For it to be continuous, right, it has to have no gap. Do you see? There's no gap here. You see how there's no gap? Right? There's no gap, right? Are there gaps here? No, there's no gap, okay? Are there gaps here? There's no gap. Are there gaps here? There's no gap. Right? Are there gaps here? No, there's no gaps, okay? So these are continuous. Okay? I don't understand. I do not know how to explain it. I don't know how to explain it further for you because you're not asking a more specific question on where you're getting confused. Okay? I'm not connecting anything here, so I don't get what you mean by connecting the lines. Okay? Let's go to 41. Edward's asking about 41. Okay? Alright, let's go to 41. I think this is 41. No, hold on. Nope. Let's cross that out. Let me copy paste 41. Wait. What's your question, Edward? If not 41, then what question then, Edward? Edward. 20 more minutes. 20 more minutes. Let's go. Let's go. Let's go. Ask me all your questions. Come on. Come on. Come on. Ask me any question. Come on. Please explain 41. Okay. Alright, let's see. Alright, let's see 41. Oh, wait, let's look at 41. Okay. Let's see. Where's 41 at? Okay. So, here's 41. To get internet at home, you need to pay a one-time installation fee of $100 plus a monthly fee of $60 per month for the internet. Write a function rule that gives the total amount for the internet. Alright. Okay? So, let's look at some important parts. To get internet at home, do you care about this part? No. Okay? Take that out. You need to, right? You need to pay a one-time installation fee of $100. Ooh, that seems to be really good information, right? So we're gonna, right? We're gonna put that down here. What does this mean? What does this mean? It means there's a flat, right? There is a constant term, okay? Right? Of $100. Good? Right, this is what this means. Okay? Okay, that's what this means. Okay? Next, it says plus. Ooh, plus. Okay? So we have to add something. $60 per month. Oh, wow. Per month. This is very interesting. Okay? Per month. So this would be a what? Okay? Right. This would be your variable term, because why is this a variable term? Because it varies based on the amount of months. That's funny. Months, right? It varies based on the amount of months. Okay, so we have to put a variable to it. Okay, right? So your total cost is your flat $100, right? Plus, do you see the plus here? Plus your $60. Okay, and you have to put per month, so X, right? Let X be equal to the months. Okay, there you go. So this would be the answer to 41. Okay, Edward? Alright, so you're asking about what is the independent variable? I'm confused. Is the independent variable is the x-axis and the dependent variable the y-axis? Okay, ready? I'm gonna make your life very easy. Okay, I'm just gonna grab a graph. I'm gonna grab the graph from the review sheet. Okay. All right. Good. Ready? Let me put up paint. Okay. Ready? Ah, that is ugly. Okay. let's make it a little big. Okay, do you see that? Can you see that? Is that okay? Ready? I'm gonna make your life very easy. Ready? Right. This is the x-axis. Okay. You could also call this the input, and you could also call this the independent variable. Okay. This here is the y-axis. You call this the output. You could also call this the dependent variable. Okay? There you go. Does that answer your question? Okay, the way you want to think about it is, do you see this? Do you see this? Do you see this? Do you see this? Right? You see how this is input? Right? Do you see how this is input? Right? 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 This is also independent. Okay? That's how you want to memorize it. Bum, bum, bum. Okay? That's how you want to memorize it. 14 more minutes, guys. 15 more minutes. So, come on. Ask all the questions you can, because in 15 minutes I am going to bed. I am very sleepy. So, all this math is making me sleepy. That is the problem. Should we leave the solution as an improper fraction if you are dealing with fraction? Yes, leave it in terms of improper fraction. 31 and 32. Okay. Okay. Let's do that. Cancel. Okay. Good question. Good question. 31, 32. Okay. Over here, and let's see if I can paste the answer. Alright, cool. What is the Y-intercept? What is the Y-intercept? Okay, this is 31 and 32. Okay. Okay. Let me pull up Paint for this example, right? Just to look at that here. Okay. So, okay, let me make this a little bit bigger. Okay, so the y-intercept is defined as the y-intercept, right? Let me just define this for you. Y-intercept is where the line passes the y-axis. Okay, this is the definition of the y-intercept. Okay. Okay. So let's do that. If that is true, where does it cross the y-axis? It looks like it's this point here. Okay, it looks like it's this point here. This point here. This point here is, right, the order pair xy. What is the x here? It looks like it's 0. And what's the y here? It looks like 120. Well, 1,200. Okay? Do you see that right here? So that is the order pair, right? So the answer, okay, for it is exactly like what the Paint gives me. Here, I could even drop this Paint picture for you here. Boom, here, drop this, delete that, boom, in front of text. There you go, right there, just for you. So, the y-intercept is the point 0, 1,200. Boom. Okay? Now, what does the y-intercept represent? Remember, we have something that we say with this, okay? We say if, okay, blank, x value, then right? Right, space. Then we put the x-axis. Okay. Then we write the word then. Y value. Okay, space. Y axis. Alright. So, okay, this is how we answer this format. Alright, so let's just do it. Okay, let's just do it so you can see how it works. Okay, what is the x value here? It's 0. Do you see that? It's 0. What's the x-axis? The x-axis says it right here. The x-axis says it's the year since laptop released. Okay, comma. Then what's the y value? 120, right? And that's a price, so we put the dollar symbol. What's the y-axis, right? That says it's the price of laptop. Okay, so read it in a sentence now. Okay, if 0 years since laptop release, then $100,000 and 200 is the price of the laptop. So in a sentence, right, if you want to read that in a sentence, right, 0 years is 0 years would be the what? 0 years would be it's when the laptop is released, right? Is newly. I think some people use this word, right? I think that's how you spell newly. Yeah, newly released. Okay, right? This is what this means grammatically. Okay, right? Then, right? What does this? Right? Right? Then the price is. Right? This is what it would look like if you're just following the format. Okay? But this is if you want to change it to make it grammatically correct. Okay? Yes, the test is tomorrow. Okay? The test is tomorrow. Okay. So, 8 more minutes. 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 Okay? Because Mr.S needs to go to bed. I am very sleepy. Doing all this math makes me tired. Do math every day. Every day. Doing math every day. The struggles. Any more questions? Any more questions? Any more questions? So you can use any of those sentences and you get it right. Yes, this is like the template right here. This is like the template to explain anything. Right? Right. This is the template, right? Right. You could insert anything else, right? Here, let's just pull something, okay? Let's just pull something here. Graph of students height h. What do you mean? Like, I don't get the exact question, dude. Like, Edward, I don't get what your question is. Like, so let's just use this format for a different graph, okay? Hold on here. Let me put the graph up, okay? Right. Here's the graph. Okay. In front of text, okay? Right? Let's grab this, okay? Alright. Okay. Let's see what this means. If, what's right? Let's grab a point. Let's grab a point. Let's grab a point. Okay, let's grab a point. Okay. Let's grab a point first, okay? Let's grab the point here. Okay, let's grab this point. Red. Let's grab this point. No, hold on. let's grab this point. Right? The point here is 1, comma 40. Okay? Alright. Ready? Look. This even helps you with the what the if and then statement is. Okay, in front of. Okay, alright. Ready? Okay, ready? Okay, let's go. Ready? If, what's the x value here? 1. Okay? 1. What's the y-axis, right? It says it's the speed of toy car. Okay? Then, what's the y value? 40. Okay, and what's the y-axis, right? Then the height of the ramp. Okay? Boom. So, it reads this, right? This is the sentence, okay? If the speed of, no, if the speed of, if the speed of the toy car is 1 meters per, right? If the speed of the car is 1 meter per second, then, okay, comma, then the height of the ramp was 40, right, centimeters tall. Alright? That is a better description of this. First time we know. I'm confused. I came in a week late into your class, so do I skip writing the essential question for the first week? No, you still gotta go write the essential question. Look at the PowerPoints. No one's excused. There's PowerPoints with the essential question. Don't be lazy. The essential questions are very important. It gives you it makes you look at the bigger idea, right? So it's very good for your brain. Okay. Number 5 on review. Okay, wait, hold on. I think we gotta review 5. Luke asked for 5. Hold on. We don't wanna skip Luke's question here. 5. What was 5? 5 was this, right? Okay, let's do 5. Luke's question here was this. Right? And this was asking us to evaluate the expression. Okay? Evaluate the expression. Right? Boom, boom. So, first of all, deal with the most inner one first. So I'm going to deal with this. Right? I'm going to highlight it 0. Okay? Notice how this becomes 3. Good? Right? Do you see that? Do you see that, Luke? Next, right? This is attached via multiplication. So you have to do the multiplication first. Okay? Right? This right here, this is multiplication. So you have to do that multiplication. So this becomes 15. Okay? Do you see that? Do you see that? Do you see that, Luke? Do you see that, Luke? Skywalker, Luke. Look. Right? 5 times 3, 15. Good. Now you do the subtraction. Okay? Now let's do the subtraction. Okay? 4 subtract 15. Alright, I can even make that blue for you. Hopefully you can still see it. Can you still see it when it's blue? Okay, hopefully you can. Right? And this becomes... you can't see it. Let's make that pink. Make that pink. Yeah, okay, you can see it now. I think you can see it, okay? Alright, so now you multiply it. So this becomes negative 22. Okay? See? You see? Look. Look at the steps. Right? It multiplies, so this becomes negative 22. Okay? Right? You see how that came to be. Right? Then you add that together. That should get you negative 15. Right? That's the no, hold on. Right? This should get you negative 15. Right? Is there an error on the problem? It looks like that's correct. Okay. 3, 15, 4, negative 11 plus 22 plus 7. Yeah, that's it. So that is the worked out. Right? You have to deal with the most inner one. A lot of people get this step wrong. Right? This is the most dangerous step. Here, let's just put that in the step format. Okay. Everybody, I don't understand why everybody gets this wrong. Right? From this step to this step. Okay. You have to be very careful. Okay. You have to see that 5 is multiplied with 2 the 3. Okay. You have to see that. A lot of people will do this 4 minus 5. Which isn't, you know, which shouldn't happen like that. Okay? Alright, so that is the 8 o'clock time. So thank you. Okay, so right, it is now 8 p.m. Thank you all for coming to the chapter 1 test review. Okay. Okay. Right. And okay, image. Let's just grab, where is that? Okay. Alright. Thank you for coming. Alright, it is now 8 p.m. Thank you for coming to the Chapter 1 chess review. Alright, good luck studying, and I will see everybody tomorrow. Alright. Yes, notebooks are due tomorrow as well.